This is 10.6, and today we're going to talk about segment lengths in circles and outside of circles. It should kind of say both of those. First, we're going to go to the theorem card. We're going to fill in three boxes, three theorems. I'm just kind of separating here. So, oops, let's try this. So there's 10.6 and those three boxes. Okay, so first one says if you have two chords intersect inside of a circle, so they literally just cross, kind of make a T, then A times B, so this one chord cut into two pieces, they're not necessarily in half, but that chunk times this chunk, and then your other chord, it's two chunks multiplied together. They equal each other. So AB equals times CD, or I'm sorry, equals C times D. So here's an example of that. 14 and 15 are on one chord, so they're together, and then 10 and X are on the other chord, so they're together, and then we just do a simple solve from there. Multiplication, multiplication, and divide. Second one says if two secants share the same external endpoint. So meaning that these two secants come together and they meet at a point outside of the circle. So the vertex is outside the circle. So if two secants do that, here's where it gets a little confusing. It's a lot going on. So A, which is the section on the outside, times A plus B, which is the out plus the in. Or you could even write the whole secant, so the whole length, equals, and then you do the same thing on the other one. So the outside part times the outside part plus the inside part, or again, the whole thing. So sometimes, just depending on how the picture is, you could do outside times whole thing, or you could do outside times out plus in, so like that whole segment. So here's an example. So the outside part is 8, bam. Then the outside part plus inside would be 8 plus 19. The whole thing would be 27, so that's, you could also put that there. Equals, on the other side, you've got outside, 9, times outside plus inside, so 9 plus x. And then that's, again, just an algebra problem, all multiplication over here, and then you can distribute your 9 and finish solving. Last one says if a tangent, so that's this guy, because it's going to meet the circle at one place, so it does not get chopped up into any pieces, not like these got chopped up because they hit the circle, or these because they hit each other. So if a tangent and a secant meet, then, so here we go, the one chunk that's by itself, so the tangent section, that actually gets squared. It has nobody to times by, so it gets squared. And that equals, and we're going to do the same thing we did up there. So outside, B, times the outside plus the inside, so B plus C. Here's an example of that. So 24, that one's by itself, so that's squared, equals, and then you've got outside 18 times outside plus inside, so 18 plus x. Again, distribute your 18, solve it up. But those are your three 10.6 theorems. Also off to the side, I wrote that these are to deal with segments. In our 10.5 lesson, all of these had to do with angle measures that we were finding, degree measures. Down here, we're talking about segment lengths. So even though some of the pictures are the same, this picture is like, oops, sorry, this picture is like this one or this one. So they look the same. This picture right here looks like that one. This is finding an angle. This is finding a segment. So just make sure you're kind of looking at that as to what you're trying to solve. Let's do a couple problems here. Two vocab words. How about that first? So a secant segment is just a segment that contains a chord, and we've already done this word. So a chord is made up of it. So there's the secant part, and then there's an external part. The part of the secant segment that's outside the circle is the external part. So that's that. Not really a big deal that you know those things, but we were just talking about on the blue card how you have external parts and then internal parts of the circle. And then you can also have tangents where they just hit the circle at one place, and that's it. So a couple of examples that we're going to do. First one says solve for x. I'm literally going to go to my blue card. I'm going to figure out which one of these pictures it looks most like. And that one looks most like this one. So two chords, they're crossing in the middle, not in the middle, inside the circle. And so this is the formula I'm going to use, which just says Each chord that gets cut up, you just take those two pieces and multiply. So this chord, when I trace it, is the x and the x plus 4. This chord, when I trace it, is the x plus 2 and the x plus 1. And now my job is to just solve that. So I'm going to distribute the x here. I'm going to get x squared, and x times 4 is 4x. Over here, we're going to FOIL, so I'm going to get an x squared. I'm going to get a 1x. I'm going to get 2x, and I'm going to get 2. I'm going to try to move the x squareds together, but as soon as I try to do that, they both cancel, so that's kind of nice. I'm going to put my like terms together, and then we're just going to move the 3x over. And as soon as I do that, I just get an x equals 2. Next up, going to my blue card again, I'm going to figure out which picture this looks the most like out of the 3 that I'm doing today. Not that one. So they're meeting on the outside, and I have like 4 pieces. So that's this guy. So A, B, C, D. I got 4 pieces here. So that's the formula I'm going to use. And that formula says that you take the outside, so 6, times the whole thing. So outside plus inside, 6 plus 4. Other one outside is 5. Whole thing would be 5 plus x. So doing a little math here, I got 6 times this is 10. I can distribute, so I've got 25 plus 5x. This is 60. Then we're going to minus the 25 over to the other side, which gives us 35 equals 5x divided by 5, and I have 7. One more to go. For our last picture on our blue card, this is the 3rd box. So the 16 gets squared because it has nobody to multiply with. There's no other number on its segment. The other one is the outside, which is x times the whole thing, which is x plus 8. So 16 squared is 256. And then I've got x squared and I've got 8x. Cannot get rid of the x squareds. It doesn't work out like the last one. So I actually have to move that 256 over. And then once I do that, I am now set up for the quadratic formula. So love that for us. Our A value is 1, our B value is 8, and our C value is negative 256. So here we go. X equals negative B plus or minus B squared minus 4A and then C all over 2A. Just doing some simplifying. Grab my calculator quick. So I've got 8 squared minus 4. I don't need the times 1. And then times negative 256. So it looks like I end up with 1088 inside the root. All over 2. Let's see if 1088 square root's nice. It does not, so that's unfortunate. So I've got negative 8 plus or minus about 32.98 divided by 2. So we're going to do negative 8 plus that 32.98 and then divide by 2. So one of our answers is 12.5. And the other one is negative 8 minus the 32.98. And then we'll divide by 2. And our other answer is negative 20.5. And it does not make sense in this problem for this length to be negative. So we won't be able to use that one. We'll just use 12.5. So make sure when you're doing your problems today, check the picture, match it up to the blue card, and then follow that formula.